Okay, so I have started the recording. So this is the like the employee one is the employee Rahul Roniar and like the 100,000, and this is calling a method of a class. So and so EMP1 become an object. This will be called an object, and we are calling the method full name on this object. Okay, so this is clear. So we can call the second object of the employee class emp2 employee with the first name Subhan, second name Roniar, and the like the pay is 120,000. Okay. So similarly, we will see that like the we can keep the some variables or some attributes outside any functions, like the raise amount is kept here, number of employees here. So this becomes these two variables become the variable of this class, not the variables of any object. Here the first name will become the variable of a particular object. So if we print emp1, like we can print here emp1 dot then first name. Emp1 dot first name. Emp1 is not okay, underscore. So emp underscore dot first name, and it is giving me Rahul. Similarly, how the variable or class different from a global variable? I will come to that. Just give me a minute. First, I will explain what is the difference between a class variable and a variable of a object, like the if it is inside some function. Then I will tell the global variable. Like suppose here we are printing employee to dot first name. So this both here the value of variable for both different two different object emp underscore one and emp underscore two is different. So this becomes all the like the attributes which are inside the any functions or at init functions with a self keyword, it becomes the attribute of a object, not the attribute of a class. Whereas here it becomes the attribute of the class employee, not the any object. So it is the raise amount is 1.04 and number of employees 0. So it will be global to all the object. Any object for any employee, the raise amount is same 1.04. Be it manager, be it any employee, any kind of employee, his raise amount will be the 4% only. And as we will increase more and more, like the employee, we like the logically we should increase the number of employee, and number of employee will be global. So say here we are, so let us say it is employee 2. To make it like the distinction, let us make it imply 2, and like here imply 2 and here imply 2. So imply 2, yeah, in the init function itself. So while initializing, it is increasing the number of employee plus 1. So it and here it will display the name same as before. It will apply the raise salary self dot pay into self dot raise amount. It should also consider the experience year. So that okay, so employee 2, then we created employee underscore 1, like the employee 2 underscore 1, employee 2 underscore 2 will create. So we will see employee 2 underscore raise amount. So first we should see the like the because we have created 2 employee 2, right? So I think the number of employee we should print. Hmm. So number of employee, if we print like the employee 2 dot uh, number of employees. So it is giving me a 0 now. So employee 2, it should not give 0. It's 2. So at that time it was not initialized properly. So I think I have missed the running this code. So now it's 2. And what about if like if I tell like I want this, the value of this variable. It is also 2 because it is a class variable. So class variable, it will be the same. So even if we call the print on second one, it will be the same. Unlike the first case where there, like in case of the self dot first name and last name, it might be the different for different objects. But if it is a class variable, it will be the same for all the objects and the class. So you can access using the objects. You can also access using the class name. Okay. So here, suppose implied 2.1 raise amount is 0.5. So here I will paste. So it is printing all the variables of employee 1, first name Rahul, last name Raniar, pay 100,000, email Rahul Raniar at company.com. So if we print similarly the all the attributes of the employee class, it will print the functions employee dot full name and the dictionary attribute dictionary of the employee objects weak reference attribute weak reference of employee objects doc none. So it has the like the class has the two things. One is the function init function, another is the full name function, and the other thing is that attributes is the number of employee num of employee. Yeah, no, this is the attributes of objects. This is the attribute of object, this is the attribute of a class. So class have the two functions. One is the init function. It is telling that init is a function, one module main, and that full name is a function. And that in the dictionary we have a dictionary of employee objects weak reference employee objects doc and none. So if we print the employee dot raise amount, we have already seen it should be the same. um, Print employee dot raise amount has no attribute raise amount. I have run this class. Okay, okay. It is employee underscore 1. So that's why it is not getting. We have like the employee 2 underscore 1. Here we are getting employee 2 underscore 1 and employee 2 dot dictionary. So we were printing the wrong results here. So it is employee 2 underscores. That's why now the raise amount is coming. This attribute was missing. Number of employee is coming. Init function is coming and the full name function is coming. So these three things was missing because we were not calling the right object. Right object is employee 2 underscore 1. Right class is employee 2. So these are this becomes the attributes of the employee 2 underscore 1, that is a object. This is attributes of object and object of employee 2 class, and this is the attributes of object attributes of employee 2. So here we are now we are interested in knowing the employee two dot raise amount, employee two underscore raise amount, two underscore two raise amount, and two underscore number of employee. So we have already seen here like the because we are getting the different raise amount for employee 2 and employee 2.1 and 2.2. Why is that? Are we increasing the raise amount? Employee 2.1 raise amount we have changed to 1.05. So the class object attribute has been changed. Yeah. So because class is inheriting the objects, but we have changed this class objects attributes. So it implied to we are getting 1.05. Other the class is still the implied 2 underscore 1 and implied 2 we are still getting 1.04. So now we'll see the class variable, class method, and static method. Before that, we'll answer the question how the variable of class different from global variable. Global variables can be accessed by any class, any functions in that file. If it is a global variable in that scope of a file, if it is a global variable across the whole like the library, that it can be like the accessed by any functions, any files in that library. Whereas the class variable still it can be accessed by only that particular class variable. And if it is a object variable, it can be accessed by only uh, object of that particular class, and the different object of the same class might have the different value of that variable. So I hope this clarifies the things. So class variable, class method, and static method. So here it if we are writing like decorator like at the rate class method, we don't need to like the create object to call this method. We can directly call this method using a class name. So yeah, so pandas dot data frame. So and like yes, pandas dot data frame will be one example. The pandas dot data frame is a class. Yes. For that instance. Like dot shape will be attribute. Yeah, dot shape will be attribute. And pandas become a library or a module, and inside that data frame is a class. And so data frame dot to CSV is a method. And like the to CSV to save the CSV file, to Excel is a method, and read underscore CSV is also a method. Dot group by another methods are also yeah method. Yeah. So anything object dot method. So dot is used to access the attribute or the method. So like the if what is that method is the to CSV, from CSV to Excel, from Excel, and anything dot like dot shape is a method also. Dot shape is a method, and any attribute of data frame. Attribute length columns dot columns is a attributes of a data frame object. So when we call dot columns, it returns a list of columns names and the index. So even dot index is a attribute. It will show index values at JList. So yeah, and like hmm, hmm, hmm. So we are discussing the class method and static method. So static method, like the we will see this example here. Suppose in the this like the for the class method we have to use decorator at the rate class method. For a static method we have to use decorator at the rate static method. So we have a class employee here. We have a like the class variable raise amount, class attribute or variable raise amount, float 1.04, number of employee 0. So as soon as we instantiate a employee, it will like the initialize first name, last name, pay, email, first dot last at the rate company.com. It will increase the number of employee by 1, it will display the full name. On calling the full name method, it will apply the raise. Whenever we apply the raise, it will raise the payment by like the raise amount percentage. So it has the class method set raise amount, so we can set the different raise amount for different person or different like the different class. So it will take a class and it will take an amount and it will set the raise amount. It has another class method from string. It will take a class. It will take a string emp underscore string, and it will assign the like the first last pay, and using the separator underscore, it is minus, I think, hyphen minus. So and we have a static method is work day, whether current day is a work day or not. If day dot weekday is equal to 5, so it will take day, and day dot weekday equal to 5, or day dot weekday is equal to 6, return false, otherwise true. So we'll see that we are taking a class of employee here again. So we have to run this class. So it has run. So we are taking objects of this employee class. So employee underscore one, employee underscore two, as employee Rahul, first name we are providing Roniar and 100,000. In the second case, Subham Roniar and the 120,000. So we are printing the class method employee dot set raise amount. So, so it will change like the it will change the raise amount like the employee dot set raise amount. So we will see that what is the after this, what is the employee dot raise amount. And so like employee one dot raise amount, employee two dot raise amount. So when we run, so all three will be changed, because the raise amount is the class variable, not a variable of object. So even though we like the end, the set raise amount is a set raise amount is a class method. So we can directly call it on the class. We don't need a object to call this method. And the raise amount is a class attribute again, so it will change the attribute of both the class and the object. So all three raise amount will become 1.05. So if like the we are passing a employee string one John Doe uh, 10,000, employee string two Raj Gupta 50,000. So we are making a new employee from a string, and when we will from string, yeah. So we will call the employee from string, and again it is a method of a class. So class method we can directly call on a class without making an object. So employee dot from string empty str1. So when we will print new underscore employee underscore one dot email and new underscore employee underscore one dot pay, we will get as John like the this is email John Doe @ company.com, and its pay as 10,000. So but like the here, as we know that full name is not the class method. So if we try to like the let us try to call the full name. So full name is missing one positional argument self. So because full name is not a class method, we will not be able to call on directly on the class, but we can call this on objects like emp, like first like control Z, we will show this, and then again we will show like this, control V and emp underscore one. We can we can call this on object. Whereas the from string in is a method on the class, so we can directly call it on a class. Okay, so similarly my date is date time dot it is a date time is a again a library here, so date time dot date, it will initialize a class of a date time. So if we see here, so if we see the help, my date, so it is a date kind of class. So it is like the built-in object, it has the date, like the date as attribute, class attribute, date objects it will return, and the methods here add self value equal to return self equal to formats greater than get attribute return self greater than value has less than equal to return self less than value r add reduce, so like the mean equal to date time dot date, like this is the example. And we can also tell that date time dot time delta days equal to 1, so like that. So it is one of the important like the library, whenever suppose many times we want to name a folder based on the current time system time, so that time date time module comes handy. So we are suppose we are running the same program again and again, and we want to run all like the keep all the outputs of that program under the directory name with the date time. Yeah, and also it is useful for the time series data analysis. And suppose you want to like the extract, you have a date time object, or you want to keep date time object, and from that you want to extract hour, day, date, or anything. So at that time this will be useful. So whenever we will print my date is date time dot date, and employee dot is work day my date, so it will give true, because it is a like the it will be work day, it is not a holiday, so we are calling directly is work day on a employee, so it is a static method. We don't need to like the uh, create a objects for the static method. So I think any doubt, we will take 2 minutes to resolve any doubt if you have. So then we will proceed with another example, banking information system, and then we will wrap up the class, and we will try to briefly see the modules. And after that we will see the basics of machine learning and regression and the classification problem. So I will wait for 2 minutes for any doubts. If you have any doubts, please write in chat. So I think nobody has any doubts. So like the class method takes the CLS as a first argument, whereas static method doesn't take class CLS as a first argument. So if we see here, like the here the class method is taking CLS as a first argument, whereas general method was taking self as a first argument. And in the static method, we can't access or alter any attribute or state of a class. So we can't access self dot first. We can't access or change raise amount, number of employee in static method. Whereas in class method, we can access as well as change those things. So now we will see the bank method, and using this bank information system, we'll see the parent class relationship. We will see that it is called inheritance. So the like the things like the we have already seen the encapsulation. We can decide based on the attribute or the way we are defining the class and the method. We can decide which method, which attributes can have what kind of access. So this is called encapsulation. Next is called inheritance. So these are the two things, like the uh, few of the things like encapsulation, inheritance, and there are more thing like the I'm forgetting those terms now. So like the overriding, and I will complete it after the class. So there are few more, two or three terms: encapsulation, inheritance. So inheritance, if we understand like the in general term, in Indian system or in any system, like the a son or a daughter inherits the property of its parents. So this is the simple example of the inheritance. So whatever the property is earned by your parent or your father or mother, it will be like the inherited by you. But if we go about the law, you have only right uh, to the inherited property of your father, what he has inherited from his grandfather or grandmother. What he has earned, he can decide whether he want to give it to you or not. So but what he has inherited from his parents, on that property you legally have a right. So by the rule, but by the legal rule. So but yes, in contrast, like the your parents doesn't have legal rights on your property. So like the subclass, we have a class and subclass. So subclass is like a child of a class. So subclass can access any property, any functions of a class, but subclass can override also the property or the functions. Suppose like the like we have a class named as vehicle. So I'm just taking a brief example. Vehicle is a class, and so I will write here. uh, so suppose we have a class called vehicle, and we have a subclass called car, like the bike, and so on. So all those have the number of wheels and the other property, but like the suppose a vehicle have, suppose we are considering greater than equal to 4 wheels. Suppose it has a property that it has greater than equal to 4 wheels. So it may be changed. It can be changed that car has exactly 4 wheels and bike has exactly 2 wheels. So it can override, it can directly access the attribute or a functions, or it can override the attributes or a function of its parents. Okay, so bike, like the two wheel. So So here vehicle is become the like the class, and car and bike are the subclass. Okay, so here we are defining a class user which has a name, age, gender, and it will show the details. So details is a method which will show the user details, name, age, gender. Whereas bank is a subclass of user, and the syntax is that inside the bank we like the bracket we are using user. So bank becomes the subclass of user. So any object of bank will have a name, will have a age, will have a gender. If we go by like this, the definition, like any, whereas it becomes illogical to bank to have a gender, but it will have the gender according to this structure. If we see this structure, because bank is a subclass of user and user has name, age, gender, so bank will also have name, age, gender. Okay, so user have the show details method, bank will also have show details method. Whereas bank can add more attributes like balance, bank is adding more attributes like balance, and in this way it is initializing the name, age, gender, super, like the it is referring to the super class. So super class means user, and it is initializing the name, age, and gender, and it is making one more attribute, balance. So whereas bank can access attributes and the functions of user, but user object cannot access the attribute or the function of a bank, like the user object cannot access the balance. So user object cannot access the deposit, user object cannot access the function withdraw, user object cannot like the have the balance check. Okay, so if we run this, so we are making an object of a bank as user one, instead we should make bank one. If we are making here, so bank one, and here bank two, and then bank one dot balance check, and bank one dot deposit, then bank one dot withdraw, bank one dot withdraw this, bank two dot balance check. So we are initializing a bank object with name Rahul Ronyar. So the bank account of Rahul Ronyar, age 30 and gender male. Bank account of Subham Ronyar, 26 and male. So we'll check the balance. Suppose we'll check the balance here, and then we'll deposit in the bank account 100. We will withdraw 21. We will withdraw 500. So we will check the bank two dot balance check. So we'll here we should check the bank one itself. So user details, by default it will show the user details of one, name Rahul Roniar, age 30, gender male, the available balance 0, balance has been updated, the available balance is 100, the balance has been updated, available balance is 78, insufficient amount when he tried to withdraw 500, and then when we check the uh, balance check, so balance check is showing the show details. So show details is like the show details is the method from the user. So although bank doesn't have the show details, but bank is a sub, like the subclass of user, and user have the show details, so it can access the show details method. So it is showing the name, age, gender. So it is showing the name, age, gender, and it is showing the available balance also. uh, it is showing the available balance. So details self, user details self, raise name. So we it should not see. Okay, print the available balance after calling the show details. It is showing the available balance, so that's why it is showing the available balance is 78. So I hope this is clear what is meant by the class and the subclass, and relationship between like the child and the parent. So this is the end of the class. So like the end of the class topic, not the class. And so now I will briefly show you the files and the modules. So every file become a module in the Python. So whatever the file you will write, like if you in a directory, like I will show you the directory here. So suppose in video 3, like suppose any Python script file. Wait. So I will open my GitHub, the current program itself. I have opened and closed now, I think. GitHub.com. So today repository what I have created. Hmm. So this is the assignment that I have submitted today. And so here I have model.py, main.py, preprocess.py. So this becomes the modules itself. So in the main.py, I am importing the model, like the from model, import load train underscore data, train test NLP underscore model, load test underscore data. So these are the functions defined under model.py. And like the inside the pre underscore process, there is a function convert to SPACY format. So this is a function. So this become the modules itself. So every file becomes a modules in a Python, and you can import the functions class from there. So the hierarchy, if you see here, we have the preprocess.py, main.py, models.py. So in main.py, I am importing models.py, I am importing preprocess.py. So, and I will show you another. So this is clear. Every files can be treated as a modules in a Python, and it can be imported to other files. So, but for, if it is in nested directory or the super directory, then you have to do something other. So that I will tell later. But if it is in the same level of hierarchy, you can directly import writing the name like from model. So this was the model.py. See, defined in a model.py. Okay. So from model.py, I'm importing, these are the methods. Even if I can import the class load train underscore data, train test NLP.model, load test underscore data. So load train underscore data, see the def load train underscore data file name total. So I will open into another tab maybe. So here custom NER and the model.py. So first thing I was importing is the load train underscore data. So load train underscore data, I am defining here load train. I hope it is visible. So if it is not, I will increase the font. Load train underscore data here. I have highlighted load train underscore data and then load test underscore data. Then NLP underscore model train def train. Then train and then evaluate and so on. Just I will take a 2 minutes break. Till that time, if you have any doubts, you can post your query in the chat box. Just I will be back in 2 minutes. So welcome back. So I think you will see the like the importance of this concept as you keep using the Python more and more. You will discover the need of the class, need of the library, need of the modules. So just keep exploring. We are briefly touching the important things. And as you go on, explore your journey in the Python. So you will see more and more use cases of the class and modules and so on. So like I will show you another modules, maybe hashtag prioritized LDA. So here, see, I know. So here, see the seeded LDA. I have make it is sub module. So it is a module. I have just written init.py. So I have not written anything. So I can import from anywhere these things, any of these things from even outside of this seeded LDA. So writing this, it like the an empty underscore init underscore dot py, an empty file makes this a module. So I will use this like like here and evaluation topic model Peter. So like you will see here evaluation uh, evaluation HPLDA. So here I am writing here uh, like from hashtag prioritized LDA. So this is the module and dot special words dot LDA submodule, and this is a class dot LDA. No, this is a file there. So this is a top level module hashtag prioritized LDA. This is a submodule special words LDA. This is a file LDA underscore D underscore version underscore one, and this is a class LDA is a class. So like this is a hierarchy, and I can like the anywhere in this whole module hashtag prioritize LDA. I can import any one of these files in the subdirectory. So here I want to evaluate these different models. So inside this, so I have made this whole as a like the like a repo or a library. So here I have a init.py. I have nothing, just a blank empty init.py. So this whole hashtag prioritized LDA becomes a module. Inside that, like the inside that special word LDA itself is a module. I have defined a init.py. So inside this bigger module, this is a sub module. And inside this sub module, I was mentioning this file LDA underscore D underscore version underscore one dot py. And inside this file, LDA is a class. So like here also, like the I am the vocabulary here is a another file uh, like the file in just outside this hierarchy. So vocabulary.py. So to import this vocabulary.py inside this itself, like the LDA underscore version underscore py. So this is the how I am going from hashtag underscore prioritized underscore LDA. This is the super like the module, and this is the sub module special underscore words underscore LDA. Then I am importing a complete file. So in another case, so I will spend just 10 seconds here. So this was the outer level module hashtag underscore prioritized underscore LDA. After that, this is a sub module special underscore words underscore LDA, and this is a file. So I will be using vocabulary. If just I will type vocabulary uh, just outside of this hierarchy. It is the same. Like the self dot vocabulary, like the no, this is different. This is saving. I'm passing the vocabulary, diction vocabulary. No, this here. Like the vocabulary dot load file tweet inside this file. So this file become also a like the module kind of thing, and this is the load file tweet is a function. So another way like the here I am evaluating topic model Twitter. So I am calling all the different module hashtag prioritized LDA, seeded LDA. So if you see any of these, like the open in new tab, like here, I have defined a evaluation functions. These were the common function. So so evaluation functions. I will show you evaluation helper functions. So in evaluation helper function, see from hashtag prioritized LDA, this is the top level library. I have imported special word LDA. This is the file LDA and like LDA underscore D underscore version underscore one. This is the class LDA, and I have imported it as a HP LDA. In the second one, this is the top level library hashtag underscore prioritized underscore LDA. This is the sub library LDA underscore baseline. This is a class LDA underscore D. No, the LDA underscore D is a file, and again import LDA. So it will be imported as LDA because we have not mentioned any alias or any nickname. So the default name will be LDA itself. Now the third model. This is the top level module hashtag prioritized LDA. Then this is a sub module seeded LDA. And then this is a file guided underscore LDA underscore D, and seeded LDA is a class.
Look like complex, but it is easy once you know the Python in detail.
Yeah. So like in the same file, I will evaluate all three models here itself. So I have defined these three are the same. How I read the input and output file. So I have defined the helper functions. I have defined this, extracted this class, and I will in the single file, single functions, I will evaluate all three models simultaneously. So each module have different vocabulary file, different training function, different testing functions, different algorithm for convergence. But in a single file, which is outside all these three sub module, I'm evaluating all these files, all these models. So this is enough for the modules and the sub modules. I will try to give you some slides also today, as I was busy in my submissions, so I could not finish it. Just I submitted the assignment for my placements. So these were the assignment that I have submitted at 12:40. So this is all for the class and the module, and even like the you might be seeing showing like that we are showing only our library. So let me show you the sklearn and the pandas. GitHub. So I will come here and then pandas. So first I will show you the pandas because we have done enough of pandas in few days. GitHub.
सर्च कर लीजिए.
खोलिए अब तो.
So Pandas is also a module. Durgesh sir will join soon. So this also consists of defined sections, defined Python files like README files, and some Python Pandas such as code files. Like if you see here, it is actually GitHub where people collaboratively add codes, also review codes, approve codes, and it is an open source project. So there is a team who usually manage those codes and also approve, and that becomes our Python library that we are installing using the pip or using the Anaconda. And it contains different like Python.
So here is our main library pandas. So just you see the init.py. Okay, so here we have the init.py, and these are the sub library arrays, error, core. So if we suppose the array, here only the init.py is defined, no other thing is defined. So if we see plotting, so init.py underscore matplotlib core.py. So if we open, so it is just a documentation and it is importing from pandas, because pandas is the whole thing. So panda.plotting dot underscore core. So pandas dot plotting here dot underscore core and it was importing like the here also pandas dot like the in the plotting file. No, in it like the here just above hierarchy it was importing like the from panda.plotting underscore core import this plot sr box plot frame like this. So init py it is just importing above and it is defining what are the names that will be defined here in this submodule. So uh, so group see here the pandas, the bigger module, core submodule, group by sub module, and then the different files base.py, categorical.py, generic.py, group.py. So if we open any file like base.py, like the here output key, it is a data class data class, common allow list, quantile fill na, like that series apply allow list, data frame underscore apply dot allow list, frozen str count correlate. So these are the reduction kernel frozen set. So because all these library are like the written in the low level things, so they are pre-compiled. They are used most of the time. They use the pre-compiled code so that the things go like the becomes really fast. So like group by, if we open group by, so function tool, partial wrap, inspect, callable, hashable, iterable, list, literal mapping, import numpy as np, import pandas dot errors, uh, group by, indexing, mixing, nth selector, uh, like
See the scrolling bar.
like class base group by, it all the class will inherit this base group by pandas object. It will take pandas object, selection mixing, and nd frame t group by indexing mixing. So you see any other class it will inherit this. So big single.
It is going on from 2010. That means 12 years.
So here see you see count method was there, all method was there. uh, so I have seen somewhere count method, and you might be seeing Python underscore Python. So transform number preparation, somewhere I have seen count.
Bin count.
Def count, compute the count of a group excluding the missing values. So like this. Now I will show you the another sklearn. So sklearn, it has the examples. Then there will be the main package sklearn. Then there are many sub packages like the model selection, mixture, matrix, semi supervised neural network. So if we go in the like the naive base pi, random projection, setup.py. So I will go into the linear linear model. So linear model like the base pi Bayesian Bayesian regression. This is Bayesian regression. It is importing other relevant package class Bayesian ridge regression. Bayesian ridge regression. This is taking two. It is inheriting two subclass. It is a children of these two class, and these are the parameter of the class. And see this way whenever we give the help, so these things comes all inside that triple quote. So those who have already used PyCharm, they will suggest to document every class, every functions like this. So this much, whenever we take help of this class, this anything that is inside this triple code, this will come as a help. Yeah. So you see the documentation how they have written. They have first written what is the name Bayesian ridge regression, what does it does in 2 or 3 lines, fits a base ridge model, what are the parameters that it takes, an iteration in default 300 TOL, stop the algorithm if W hat converge, alpha 1, alpha 2, lambda 1, lambda 2, alpha init, lambda init, compute score, normalize, etc. So then it has init function, and so it takes so many argument and then it initializes like this. So then it has a fit self xy sample weight none, then it will have the predict. So then update coefficient, log marginal likelihood, these are the functions. So even this another class ARD regression, Bayesian ARD regression, it is the subclass of again the same two class regression, regressor mixing linear model. So this is the end of the class and the module. So we will take what is the time now? 4:38. 4:38. So we will start but after 10 p.m. So 4:40, 4:50. Huh? 10 p.m. 4:50, 4:50 or 5? 4:50. We can go for 5. It will be for 1 hour class. Yeah, we can start at 5. So we will complete the brief overview of a machine learning, what is supervised learning, what is semi-supervised learning, what is unsupervised learning. We will try to show the example of regression and the classification. And if required, if we could not cover something, we will give the notes and the other files, because again the machine learning is a huge thing, and somebody also 1 or 2 people were requesting to cover the deep learning. We really wanted to, but I think it will be difficult to cover that in remaining 1 or 2 hours. We have already covered from the scratch of the Python, starting from the setup to the data structure defined in the Python, to the for loop, if condition, and then the pandas library, then the plotting library. In the plotting, we have covered Matplotlib, Seaborn, Plot9. We have covered Plotly. We have covered the details of the dictionary. We have covered the statistical computing, SciPy. We have covered even the class. We have covered the functions, modules. So in the 6 days or the 3 weeks, we have covered a so lot of thing, and we will continue the support in the like the teams till the next month or next to next month. We are like the free to help you with any query. Even and we have also shown the like the how to solve the differential equation, how to solve the optimization problem in the Python. So we'll resume the classes with the like the basics of machine learning. We'll first introduce the what is the three type of problem that we solve in machine learning, namely supervised, semi-supervised, and unsupervised. Then we will briefly show the classification and regression problem. Thank you. So welcome back everyone. So we'll start with a brief introduction to machine learning. So we'll refer the two blogs. One is the machinelearningmastery.com. This is a very nice blog. It explains the different concept of machine learning and deep learning in very simple term. So like the traditionally software is written like we have a data and we have a program which will calculate the y or the output for a data. So and we encode the logic basically how to do it. So anything changes like the any kind of data changes, we might need to adopt the program. So every time the data is changed or any logic is changed, we need to change the program itself. So this is the pitfall of the traditional programming. So every time a new scenario comes and it is not handled by our predefined logic, we have to make another program for that. Whereas in machine learning, we give the data and output and tell the program to find the relationship between data and output. And as we go on, as we input more data, more output, program will automatically learn the relationship. So relationship will get better and better with more data and more labels. So this is the basic difference between traditional programming. Traditional programming takes data and the program and creates output, whereas machine learning takes data and the output and gives us the relationship between data and output. So there are different application of machine learning. Web search, whatever we search on the Google and we get the ranked pages, it is basically the through the machine learning algorithm, they find the relationship between the search query and the pages. And based on that, it first find the ranking score, then using some other factor also based on your reason, your interest, your previous clicks, and so on and so forth, it ranks the pages. So most of the time, if you see Google, currently the top 3 to top 4 uh, link is sufficient for your query. So even it is joke that you hide something in fourth or fifth page of Google, nobody is going to find it. So it is applicable in computational biology in understanding the genes, drugs, and the having the different combination of the genes and their interaction, the protein interaction. In the finances, deciding on the where to invest, the evaluation of the risk on the credit offer, whether there is a fraud on the credit card or not. So the system will detect if there is a fraud and it will not allow the transaction. E-commerce, like the predicting the customer churn, when there will be more demand of the customer. If a customer is buying X, will it also buy the Y, like the bread with the butter, the milk, and like the sanitary pad or anything, something they will buy together, whether or a transaction is fraudulent or not. Space exploration, space probes, and radio astronomy. Robotics, how to handle uncertainty in new environment. Autonomous self-driving car, a lot of challenges yet to be solved. Like information extractions, like the question answering block or like the chatbot. Social network, understanding the relationships, the possibility of accepting forming a network, like what is the probability that you send a friend request or follow request, it will be accepted. What is the probability that your post will go viral? What is the probability that like the uh, a particular topic will go viral, a particular hashtag will go trending hashtag, or if you want to understand top 10 trending hashtag of a day, or you want to understand top 5 topics of a month that is discussed in a Twitter. Debugging in the computer program itself, can you understand the error? Can you understand if like the before running itself, like the nowadays the ID is telling you this might be the error. So kid, like the suggesting the where the bug could be. The key elements of the machine learning are the representation, how you represent data or the knowledge. Example include decision tree, sets of rules, instances, graphical model, neural network, support vector machine, model ensemble, and others. Evaluation, the way to evaluate program or hypothesis. Optimization. So the briefly, like the machine learning can be classified into the three categories, like uh, supervised, where you have a data and the labels, and it will learn the relationship between data and the labels. So it is called supervised learning. So example of supervised learning as classification and the clustering. Suppose in a mail, suppose you have a automatically your mail will go to either inbox or it will go to other folder or spam folder. So learning the relationship between like the given a mail, whether it has to go to the inbox folder or spam folder, it is example of supervised learning. So you gives machine some examples what is the like the what is the important mail and what is the spam mail. It will automatically understand the relation based on like the, and you have to of course give the important features, like it will see whether the sender is in your same domain or sender is some is puri like the suspicious domain, whether some like the suspicious content, some image, some random link is there, or some suspicious link is mentioned in the mail. So if it will go to the then spam folder, or if some attachment is like the some virus kind of attachment is there, then it will go to the spam folder. So in the yeah, we will do the link of the blogs at last of this class. So in unsupervised learning, we don't know the labels, and the computer has to find the relationship automatically. So in the supervised setup, the label is there to guide the machines to learn the relationship between X data input and the target variable y. Whereas in unsupervised learning, the machine has nothing. It has a just data and it has to learn itself without support of any labels, the like the symmetry or the grouping between that. So example of unsupervised learning is clustering. Example of supervised learning is a classification and regression. In both classification and regression, we have a label present with the data, but in the classifications the labels are discrete, like the inbox or spam, like yes or no, whether you have a covid positive, covid tested positive, or covid tested negative. Whereas in regression problem, labels are the continuous, like the price of a stock, price of a land, or say anything like the traffic, like the how much traffic will be there at a certain time, like that. Like that, it will come under the regression problem. Unsupervised problem, given a large collection of text, find the like the similar images, find the group of similar images or similar text. Given a large collection of song, can you categorize it by the theme, broader theme?
Leveling for
Yeah, like the
levels.
yeah. So like, can you like the in the Google News also, like if you see the news.google.com, it has improved a lot in last 3 to 4 years. So see, top stories for you, this is personal recommendation, and this is the categorization, business, these are the related to the business, these are related to technology, these are the entertainment, and there is a subclass here, entertainment, latest movies, music, TV, and so on. And even like the if you see the like the top stories, this is a representative title, and all related stories are here. And like the this is a representative title. So block by block it is showing. So like in the machine learning, we have the like the other area is the reinforcement learning, like based on your action you will get some reward or some punishment, and your goal is to optimize the reward. So this kind of algorithm is used to learn the chess thing, chess, like the this helps computer to learn the chess game or the complex game, robotics kind of environment that you don't know. You can't program all this random scenario in the real environment, how the robot will work, how the like the car, autonomous car will over, like the drive. But you can give, if it is like the doing some wrong action, it you will penalize. If it is doing right action, you will give some reward, and it will, through repetitive action, it will learn which are the actions that is giving reward, and it will try to optimize that. So reinforcement learning, like the in unsupervised learning, we have the clustering, recommender system, targeted marketing, customer segmentation, we have dimensionality reduction, big data visualization, meaningful comprehension, structured discovery, feature elicitation. In machine learning, we have the supervised learning, we have the classification, image classification, identify the fraud detection, customer retention, diagnostic, whether you have certain disease or not. We have regression problem, advertising popularity prediction, weather forecasting, market forecasting, estimating life expectancy, the population growth prediction. We have reinforcement learning, game AI, skill acquisition, learning task, robot navigation, real time decision. So, like overview of supervised learning, that spam and not spam. So categorical separation, spam or not spam. A new emails come, it will based on the like the labels, it will learn, and whenever the new emails come, it will either categorize it as a spam or not spam. So here labels are discrete, enables the machine to train to classify the observation into some class. So type of supervised learning, classification and regression. Classification problem, output variable is a category, red or blue, disease, no disease, spam, not spam. Category may be 2, 3 or n number, but it is discrete and the categorized. Whereas in regression problem, the output variable is real value, such as dollar, weight, price, like the flow, speed, etc. Overview of supervised machine learning. AI system is presented with labeled and unlabeled data, and it has to like the group, like suppose it is a figure, then you have to show the related figure, that these two are related figure, these two are related figure, you have to group them. In the above example, we have given some characters to our model which are ducks and not ducks. So you have to group based on the ducks and not ducks. Types of unsupervised learning, clustering and association. In clustering, where you want to discover the inherent grouping in the data, such as grouping customers by the purchasing behavior. In association rule learning problem, where you want to discover rules that describe large proportions of your data, such as people that buy X also tend to buy Y. Like those who buy bread will also buy butter similarly. So even like that, this is very useful. The whenever you go mall, they use this kind of thing. They segregate their section based on these things. They will always keep the chocolates or the some kind of this thing at the counter, and they will like they will arrange their rack based on this logic, based on the what two things are bought frequently.
Like bread and butter and milk is always in the same section is available.
Yeah.
Someone who is buying but bread, he will also buy butter or milk. That is the association problem.
So reinforcement learning, a agent learns by interacting with environment. The agent receives reward by performing correctly and penalties for performing incorrectly. The agent learns without intervention from a human by maximizing its reward and minimizing its penalty. It is a type of dynamic programming that trains algorithm using a system of reward and punishment. Even as a human, we also do, like whenever we learn a new language, new programming language, new human language, new subject, how do we learn? We do that again and again, again and again. And somebody is there to sometimes correct it, and sometimes there is nobody is to correct it. We only learn like the optimize the result, and we again like the recorrect our strategy, and in that way we become the master of that subject or the master of that skill. So here is an agent, here is an environment. Observe, select an option, action using policy. We have a policy, and out of policy you have to select an action. You have to again do an action, like it is selecting an action, it is going to fire, it got minus 50 point, it is getting the action again, it will get the reward or penalty. Observe, select an action using policy, action, get reward or penalty, update the policy, learning step, iterate until optimal policy is found. So here minus 50 point bad, next time avoid it. In the above example, we can see that agent is given two options, a path with water or path with fire. So a reinforcement learning works on the reward system. If the agent uses fire path, the rewards are subtracted, and agent try to learn that it should be avoided the fire path. So this is all about the brief uh, overview of what is the machine learning. So
Someone has asked that question.
so this term artificial intelligence start with the 1950 early artificial intelligence or streets excitement, and in late 80s the term coined by the machine learning. So machine learning can be categorized as subset of the artificial intelligence, begins to like the, and in the late 2010 deep learning. So deep learning can be like that treated as the subset of the machine learning. So deep learning based on the neural network where you have a neurons, and it is basically based on the linear and non-linear relationship through the neurons, and like the it uses the like the differentiation and the back propagation to learn the weight.
Just a complex optimization problem.
Yeah, all this is a search space or learning the relationship between the y and x, exploring the search space. So now the Rahul will briefly show you the regression problem, and he will also show you the his blog to like the become master in the data science or the machine learning or the deep learning. He has written a very nice blog with the link of the all the resources and the video lectures that are like the popular and like the highly rated in this field.
So many of you ask that question, that how should I learn all these things? So every time I get that question, so I thought I should write a blog for that, and whatever based on the 4-year experience, I have written this blog, and that covers everything that you need, and that that has the best resources. So but you have to invest time to learn something. Without giving time, you won't learn in that way. Actually, if you want to be a very good at programming or data science or machine learning, so the steps would be like that. I will go through that. We have started with the basic Python. So if you are want to refer a basic Python book, that could be this. My recommendation will be this. It is a brief and up to point book, so you don't have to go anywhere. Just you can use this for referral. A Wrangling Institute of Python. It is by Jake Vanderplas. And after that book, I will recommend, if you are learn the basic syntax, and if you want to go not want to go to data science, but you want to learn for say programming or developer part, then I will recommend this course, the 100 days of code. That will give you an extensive resource to learn the code, how to implement those, and the projects like game development, then API development, how to use APIs. Everything is available, but it is very extensive. It will take at least 3 months to complete. It is by Dr. Angela Yu, and it is one of the best course available for those who want to be a developer or Python developer or game developer, any kind of developer. Okay, and I also given that link. I will share that link later at the end of this session. And after that, I will recommend going for the Git and GitHub. How collaboratively things are built up, like Durgesh sir has already shown how the pandas code base are contributed via different persons over the world, across the world actually. So how this happens and how the changes were made, how changes are you can unchange it or you can approve it, and how collaboratively the things are going on in cloud, that could be learned using this Git and GitHub bootcamp. That is another course available in the Udemy. You'll get it in 450 rupees. I'm not promoting anything. If you'd like, you can purchase. With offer, it would be around 450 rupees, I guess. I have purchased that and I have learned through this. Next, to go for the pandas, I have already shown you the YouTube channel that is such a data school by Kevin, I guess. And then that has the list, the playlist of pandas. And if you need more detail, you can go for these books, Pandas 1x Cookbook. And it is written by Wes McKinley. So that the author also has another book. You can also go for that book. That is also good. But I will recommend this one. And next, even if you are learning Python, I will also ask you to learn at least like Google Sheets or Excel. If you would like to, because it's sometimes one resource is not enough. Sometimes you need to quick plot something, or you don't have the resources, and you can directly open in browser. You can plot something. You can, and it is very much required for industry. Or if you go, they will ask to solve the problem. How you solve the problem, that could be important, that might not be important. Okay, whatever you feel. So I will recommend this course. Then complete course on data visualization, I have already told you last day, I guess. This course is for those who want to learn for visualization and Matplotlib Python. It is also in Udemy, link is there. And next will be the Hitchhiker's Guide to Plot9. The Plot9 plots that I have showed today is from these books, and it is very comprehensive book. So you will get up-to-date codes. Directly you can take those codes and you can implement, and it is very easy to use. Similar to those are, if you are learning R also, it also has a book, Hitchhiker's Guide to R, ggplot2. Okay, so you can also go for that. Next is if you want to do special analysis like geospatial, like over the map, you want to plot the data, you want to see the corona trend with colorful graphs over the maps, then this kind of analysis I will recommend to go for this special analysis and geospatial data analysis science in Python. This another course is available. And next is master the statistics and machine learning intuition math and code. I already told you that go for this Mike X Cohen's course if you want to learn statistics for research. And that is the best course, I think. That is in 10 to 12 hours. If you're able to complete that, it will take around 50 to 20 days. If you're able to complete that, everything you will learn. It has Python and MATLAB codes. Both are there. Next will be that once you get the basic statistics, I will also ask you to go for advanced statistics, that how data scientists or real world projects are going on, projects in real world projects, how they use the statistics for data analytics. Which part is important, which part you can ignore, that book will teach you. And once you have done that, if you want to know how Bayesian statistics work, how Bayesian way the things get updated automatically, like distributions, and how to it is basically used for like A/B testing. A/B testing means before after study, like uh, giving some dose to a patient before and after, what will be the impact, like after promoting some ads, what will be the click rate. So you can once the data will come over the year, you can update your function and get the output with updated data. So that book will teach you this. And next I will ask you to also go, if you work in text data, then I will ask you to go for this regular expression course. That will teach you how to it will search through the text data or say web page, and it will find the pattern. Let's say you want to if someone asks that please list in a pandas data frame all the actress and actors name and their age and their name and age, say. So you have to scrap through all the pages. So rather than you can write you can use a web scraper and write a regular expression that will automatically identify the name and their associated age and list it out. So that course will teach you that how to do that, how to identify patterns in an Excel sheet or in a text data set like that. Next thing is MySQL. For research might not be it is useful, but for industry it is the compulsory part. So you have to learn at least one database like MySQL. It is very old and very good. It is a query language where company actually stores their data for querying and do data analysis. And next thing is now if you want to enter to the machine learning part, then you have to go through this process. First, you have to clear the linear algebra. First of all, if you are good at it, that's okay. If you're not, then you have to at least learn the linear algebra part so that you can implement. If you have to implement the machine learning codes from scratch, you have to know the matrices and some calculus part is also needed. So this course will teach you with Python and Matlab. And after that, if you want to do feature engineering, like preparing the data for machine learning, then you have to go for this book. This book is also there, and another course is also there from the same author. The author is Serdet Grill, Serdet Gali, and she's a data scientist, and she has written this book. You can also go for this book. And next is, once you have prepared the data, then you can go for this book, Hands-on Machine Learning and Scikit-learn, how to implement those algorithms with the data. And once you have that, you can also go for the feature selection of machine learning. Which feature is important? Maybe you have 1,000 columns, but it will create the burden because you need so much computational power, and also it will reduce the accuracy due to overfitting of the models. So which feature should I keep if I have 1,000 columns? That will give the maximum accuracy. So that course will teach you how to select the features that are most important for your machine learning project. And next is a deep understanding of deep learning. Once you have cleared the basics of machine learning, feature engineering, selection process, then you should step into the deep learning part. Direct jumping in the deep learning part will resolve your problem temporarily, but it won't give you the basic or a deep knowledge. Actually, if you want to learn how to implement it from scratch, then I will go ask you to go for this Mike Experience as a new course. It is all dispatched, I guess, in this January. So he's a professor, and he has created this course, a deep understanding of the deep learning with Python intro. Okay, so it will use the PyTorch library. If you want to, PyTorch usually used for basically research most of the cases rather than our TensorFlow. TensorFlow 2.0. PyTorch is very much easy to use, and also it is OOP based, so you will learn also the OOP concepts using that. And next, once you learn the deep learning, then once you have the PyTorch knowledge, then you can directly shift to the Keras part. Keras is also a machine learning library or deep learning library created by Francis Collett. He has also written this book. You can also go the step by step how to implement. Even it contains the deep learning, shallow neural network, then deep neural network, then CNN. Then also I think autoencoders are also included. That is the advanced part, and GAN included or not, I don't know. For the latest release, it might be included, the generative adversarial networks, if you would like to go for that. And next is hyperparameter optimization. So every machine learning algorithm has some parameters that you need to optimize to improve the performance. And how to do that? There are different methods like random search, Bayesian optimization, multi-fidelity models, Optuna. There are libraries are there, Scikit-Optuna, and more. So it will also teach that. Once you have that, then there is a concept also called imbalance data. When your data has imbalance class, like in our, you want to predict say this email whether it is spam or not spam, but the spam emails are say very less in your data set, only 20%. Then your machine learning algorithm will learn that all the 80% cases it is not spam, that will give the more weightage to the not spam, and so it will less able to classify the spam emails. So how to balance that? If you have imbalanced data, there are different methodologies for resampling that is also covered in this course. If you want to know that, you can go for that course. And next is, once you have done with the machine learning part, then comes the big data analytics, like handling terabyte of data, 100 terabyte, 50 terabyte of data that handled by using Spark. Also, the Python implementation is PySpark. So that way you have to go, and that is the process you should learn data science. Okay, so it is not that jumping directly to the deep learning will help you. It will mess your head actually, first of all, because it is too complex optimization problem. And to know that, first you have to start with the basic regression, linear regression, how to implement that we usually use for our research works. Then once you learn that, then go for there is a classification part. So in linear regression, also linear regression, multiple linear regression, then some penalty based regression like ridge and ridge regression are there. Then after regression, you should also go to the advanced parts like uh, the tree-based algorithms like decision trees. Then you could also switch to more advanced part like ensemble models. Ensemble models means multiple trees or multiple model comparisons, like your random forest, then boosting and bagging algorithms are there. Once you've done that, then you should switch to the deep learning part. If some problem is solved by just a linear regression, stick to the linear regression. Never try deep learning. Okay. So it will, because these model are black box models, you're never gonna know what it predicts, why it predicts like that. Like if I give an example, for example, our IIT Guwahati has automated the process for say application acceptance. Like students are applying here for PhD or say masters, and there is an automated system. And let's say the system always choose males over females. These things actually happened in one university where they have automated the process for application acceptance. Even Amazon or other companies use this to filter the CVs. So if your algorithm is biased, you have trained with imbalanced data, say more 80% with male student data previous, and you have trained with 20% in say female data. And it always 80% of time choose such a male. But unfortunately, you are not good at machine learning. So you have just trained the model and you have created that website where somebody is uploading the say CV, and it will automatically accepting 80% of the time such male. So it is biased algorithm. So the bias correction is also very much essential when you create an algorithm. And to know that, you have to go through these steps that I have given. It is not a single step. You will directly learn the deep learning and it will help you to achieve everything. Okay. So just for information, that deep learning models, still the interpretation part is very difficult because they are black box. Why they are predicting like that and what going inside, it is very difficult to interpret. Still researchers are trying to build some interpretable machine learning algorithms that will interpret this kind of complex model where billion weightage or billion combination of say arrays will be there to train or say to store the train model. So start with the simple one. Okay. So in this case, I will just go for, because we use research problem, the regression, multiple linear regression part very much. So I will show just that part. For classification, I have written a blog. Due to the time constraints, we might not able to cover, but you can go through that blog. The code are available on the GitHub. You can download, you can run, it will run. And I have written that blog that step by step, you can go with that. And this is for, I guess, so I will just first show you the that I created the linear regression part. Okay. So just to show you that how the linear regression works actually. The linear regression we use when we try to predict a continuous data. And this is the thing that I will show right now. It is for research work. Okay. So majority of the cases we use linear regression, try to predict, say, in our case, we usually use for try to predict some continuous data. What is the speed of pedestrian crossing a road? Or what is the area of say a cancer cell? Or a cancer area, like say you want to predict the area could be a continuous such variable. And like anything that is a continuous data that can be predicted with a regression, that is the regression problem where you are trying to predict a regression, a continuous data. So here I will show the simple thing that the steps how to do a regression. Basically here I will not show how to split it into a train test part and how to split it into validation part, then train with a train data, then validate with the validation data and test with the test data. I will not show. I will just show here that how in a research work, how we usually do it. Okay. So after that, once this session will done, I will share the links for the classification case where the classification is a binary classification. It is for diabetes data where we'll try to predict if someone has diabetes or not diabetes based on some certain features. Okay, so it is a classification problem because there are two classes. So in this case, I will try to show that I will use the stats model library. And how this goes, I will show. First, you have to import the NumPy, Pandas, SPD, PLT, the PyPlot module, and C1 as SNS. For artificial, which course is useful? Artificial intelligence is nothing but the machine learning algorithms together doing something. Now you will say that, for example, the self-driving car, that is a artificial intelligence actually. The whole assembly is called the artificial intelligence. It is just a terminology. Okay. Artificial is nothing but a bunch of problems together optimized to solve a bigger problem. Okay, so in a self-driving car, there could be a module which is tracking the road. There could be a module that is also trained using say deep learning, and that will tracking the module. Some deep learning algorithms say already tracking the say map. Some deep learning part automatic uh, uh, pushing the accelerator or changing the speed or reduce stopping it. So different combination of this module or these problems together is known as artificial intelligence. Actually, it is nothing more than that. It is a bunch of optimization problem that is working together to solve a bigger problem. That is the artificial intelligence. It is just a terminology, fancy terminology, nothing more than that. Okay. So cost of courses, you will get, just wait for the offers. You'll get in 400 to 450 rupees max. In many cases, it go up to 590. Sometimes it will show 3,000, 4,000. Never pay that. You will get an offer always. Okay. So first, we will load this library and our data science. This is the modules and so our objective to here, again, I will use the tip data set to show you, because if you are familiar with that, you can apply any data set where the outcome is a continuous data and it is a regression problem. So our dependent variable is tip. Independent variables are total bill, sex. If you don't know regression, I will recommend after this lecture, when this session ends, you should start watching the Brandon Folds YouTube channel. There is a plenty of regression videos. What is regression? He will explain everything in detail, step by step. That channel is so beautiful. Okay, so dependent variable is a tip. Independent variable is total bill, sex, smoker, day, time, and size. So first we need to load the data. I will go because I will not now read that read underscore CSV. You know that how to read data. Then I will create a joint plot between total bill and tip to see how it looks like, because they are both continuous. The relationship is almost linear. I have also added a linear regression term here, line here. It is almost linear. Okay, it's not non-linear. So next, what I'll do, I will try to see using a Seaborn, that is Violin Plot, what is the relationship between tip and sex. You can also check if there is an outlier. You can also go for a box plot. These are the first terms that we'll do whenever you get data. First, get the info of the data, because I'm not showing info because already I've shown several times. Okay, go for the information. So tips.info. Always check these things, okay, because you need to know whether it is a float, whether it is an object. If it is object, the plotting mechanism will differ. The next thing is the describe option. So tips.describe. So it will describe it. These things actually help you to identify if there are any mistake. Let's say by mistake I have input the total bill up to say 500. It will catch that in maximum value. Then you can see that 75 percentile is 24. That means 75% of the values which are below of this and 25 above that. So it is okay. Only the 24 rupees is the 75% should be or more. You can check this data. Okay, that's why this table is very much useful. Statistics. Again, also I'm also, because our tip is the outcome. So with tip, the smoker, it's almost similar. Just for male cases, the median is a little bit high. So that way you have to check all the combinations and see if there are any outlier. Like here you can see the tip for Saturday for it's very high due to some reason. What would be the reason? You have to identify whether it is outlier, how to explain that, because whenever this kind of extreme values will be there, it will actually impact your prediction. Okay, so next, again with time, then check for the independence. So again, for continuous data, we have to go for the correlation part to check whether they are correlated. If they are correlated, then one of the variable that you found is not necessary. You have to remove that. Okay. So for total bill and size is a discrete variable for numerical variable. This size 2, 4. It can also be treated as categorical variable if you want. Okay, so because it has very few number of levels, like 1, 2, 3, 4, 5, up to say 5 it is there. It's not up to say 20. So it could be also treated as a categorical data if you would like. Okay, So the decision will be depend on you actually, whether you will treat it as a categorical data or numerical discrete data. Then I will check the, you need to check the correlationship, because for correlationship between the continuous data, you can see that size and total bill are related. It is obvious that as the number of persons together will reach the enter the restaurant, they will pay more bill. If I go alone and if I go with 5 friends, my bill will be always more total bill. So it is related. That means if I only keep the total bill and remove this size, then also my algorithm will able to do the same thing. If I keep both those things, my algorithm, while optimizing the coefficients for the regression, it will get confused and it will give us biased estimates. Okay, so I have to remove, say, let's say we will remove the size. We will exclude the size. Next thing is association. uh, we can also plot this if you want that. So I'm using this association again function, and I'm plotting that between the relationship. This is the same thing, just for plot with plot. Okay. Sometimes we need the correlation. This correlation don't have p-value. Sometimes we need the correlation with p-values. What this p-values actually gives? It gives whether the correlation is could be 0 or not. So if the p-value is significant, so it is significantly, we say that it is not 0. Okay. So next thing, you can use the SciPy library. So again, the Pearson from scipy.stats, you can take it as a SS, and here you can type the SS dot, and it will then Pearson R. And if you give the, say, column 1 values and column 2 values, and the column 1 is set, I'm selecting, you can directly also give this here. Okay, with quotation. So I'm saving in a different variable and giving it here, rather than you can directly, directly give it here, the names, and you will place it here inside the this, or use the dot lock method. That is also work. And dot values I'm giving because I want it as a numpy array. It supports numpy array, and it will return R, the correlation, and p value. So you can see that what happens. Okay, SS. Stats is import as from okay, from okay, let it be like Pearson. Okay, so it is showing that correlation is 0.598. What it was showing 0.60, and again the p-value is significant, so it is significantly different from 0. Next thing, what we'll do, we will do the same association for the nominal variables, that is our categorical variables. And I have already shown you the Kramer's V statistics, and I'm using the association function to plot that, and taking out the four or five, including the size, I'm taking as a categorical here just to show you. So it will show the plot, and you can see, because it is symmetrical relationship, so here it is 0.31 for day and 0.13, and it is also here. So you can see the time and day are related. It is around 9.94, which is very high. Either I have to remove the day or I have to remove the time. So what I will do, I will remove the day. Okay. So remove the day. So one variable, keeping the one variable will work. Next thing, again, I'm using the TELISU to see the asymmetric association. Again, it is showing that time is related to day by 0.88, but day is related to time is by 0.41. Both is still a more than a threshold value of 0.3, or sometimes people sometimes researchers take it as 0.4, the threshold rule of thumb. So we will remove the time variable. Okay, I'll keep the day. So right now, after removal, our dependent variable still is tip, and our independent variable, the numerical one, we are keeping this total bill, removing the size, and categorical we are keeping right now sex, smoker, and day. So how, next thing, what I'll do, I will also compute the variance inflation factor. Instead of correlation, there is another terminology is known as variance inflation factor that you can also use to give a get a sense that whether the variables are correlated or not. Okay, so I'm defining a function. You can use the stats model from stats model.stats.outlier influence, import the variable inflation factor. That is our function that we'll use. So I'm defining function, define calculate VIF. We are giving the x, then VIF is equal to pd.data frame. We are initializing an empty data frame. Then x.columns, we are adding in the VIF, this data frame. We are giving a variable, this x dot column, whatever the thing we will give, the column names will be added in the VIF. This is empty data frame. Okay. And next we are calculating in a list comprehension. We are iterating through for I in range x dot shape, whatever the shape of this data set will be. For that shape, the first number of rows it will take and iterate through it, and then it will compute the variance inflation factor. Okay, so x dot values and I at that location, and it will return the VIF. So just here we have taken the copy of the tips dataset. I have made a copy so that I don't want to overwrite that. So tips.vif data, and while calculating the VIF value, you have to give it as a numeric value because sex contains male and female string. So string will not work. So what we'll do that I will apply the map function. So inside the new our tips dataset, I'm overriding the sex column, and here from the tip dataset, I'm taking the sex column and dot map male equal to 0. I'm mapping the male should be 0 and female should be 1. Similarly for smoker, no is 0 and yes 1. Then day, Sunday is 0, Saturday 1, Thursday 2, Friday 3. Okay. Similarly for time, dinner is 0, lunch is 1. And computing VIF. So tips this data, I'm selecting these columns that I want to calculate, and then what I'm doing, I'm trying this using this function, and inside the function I'm giving the x. These are the x actually, these columns. And after, this is for before removal because it contains the size also time both. I like to compare before removal and after removal what happens. And after that I've removed those things and again computed the VIF, and the results should be like this. So before it was around 9. It should be, thumb up rule is it should be below 2.5 or 3 or less than 5. But some total bill it is showing because either total bill or size both are related. And also for day and time it is around high. So after removal, what happened that now it is below around 2. Okay, so now the VI values variance inflation factor it's called. So yes, variance inflation factor. It has now been below our threshold limit, so the variables are not correlated. It has also been estimated sometimes. So next thing we will do, we will have to create the multiple linear regression. The equation will be tip equal to beta naught, it would be intercept. And beta 1 is the slope for total bill, beta 2 for sex, beta 3 for smoker, and beta 4 it would be beta 1. Let me check. Beta 1, beta 2, beta 3. It should be beta 4, I guess. We estimated, and how to estimate that? We have to import the from statsmodel.api as SM, and next we'll directly use. We are not using the logit, so I will remove. So from statsmodel.formula.api import OLS. OLS is the ordinary least square, or linear regression. The optimization, the method is known as ordinary least square. So in R syntax I will give. That's why I'm using the from the API formula API, using the formula API. So tips is predicted by total bill. Then sex is a categorical variable. So C, capital C, inside that you have to give sex, and then treatment, which one have to be reference, because whenever you fit a multiple linear regression, the categorical variable will report only one category. It will hold one category as reference and compare other categories. Like here a reference will be 0. So 0 reference is which one? 0 reference, I guess, male. Okay. Similarly for smoker, 0 reference. For day, 0 reference. Okay. And then this formula I'm giving in the OLS. Inside that OLS, this formula, and data is tips. And I'm saving in MLR, multiple linear regression, and MLR you have to call the fit function. Then it will save in the regression, and regression.summary will give us this beautiful generated summary. So here you can see that it has a R square value of 0.461 and adjusted R square of 0.448. Okay, so adjusted R square is used when we have multiple variables. It will penalize for adding more variables. As more and more variable you will add, it automatically increase the R square. So it will penalize us. Okay, so always try to report the adjusted R square. Then it also show the AIC, BIC, the log likelihood. This F statistics log likelihood shows that at least one coefficient is not significantly different from 0. So has impact. That means has impact on the any one of the independent variable. At least one independent variable has impact or able to predict the tips. So now if I see the coefficients, this is the intercept, and these are the standard error, t-value, probability values, and 95% confidence interval. Okay. And for say for interpretation of the sex, say for our base case is it is not written female, so it is written here male. So base case is female, and here it has taken the base case as female, and it is reported the coefficient for male. It is negative. Okay, so holding all other variables constant, that means for compared to female, male pays on an average less tip. Okay, that means actually, and it is not significant, not significant. So which one is significant? Significant is total bill. So 1 unit the total bill will increase our tip by 0.1057 dollar. That means holding all other variables at constant. So this way you will get the whole table that you can report directly in your thesis, in your paper. And next thing is some checks. The linear regression has some assumptions you have to satisfy. While fitting the linear regression, there are always some assumptions like the linear. Why it is called linear? Because there is a linear relationship. Okay, that is one. Then always you have to check for the residuals. The residuals check for the heteroskedasticity. What is the heteroskedasticity? Let me show. I have searched that actually. Heteroskedasticity is nothing but a let me heteroskedasticity. The prediction range, how the error are distributed. Okay, so there was a good one here. This one, like homoskedasticity is that over the prediction, if we plot the prediction values here and the gap between their actual value and what is the data set and what is the regression line will predict, that value, what is the difference? If this difference is continuously within a particular range, the variability is constant across the say predicted value, then it is homoskedasticity. It represents a homoskedasticity, and if it is a heteroskedasticity, that means it's look like funnel. That with increase in the prediction values, the error rate is increasing. That means it able to properly identify the lower range values, but not able to identify the higher range values. Okay, so here it shows error, higher error. So you can check this using first what we have saved our model in REG regression part. Okay, so REG. So what will take? First I will calculate the from REG. It has fitted values of the linear regression actually line, and that fitted value I'm copying and saving in the predicted value. This is the predicted values. Then I have the tips original values. I'm also copying the values and saving in the true values. Then I'm calculating the residuals. What is the difference between the actual value and what our linear regression has predicted? So true value minus predicted value give us residuals. Next, what I will do, I will use a Matplotlib plot, scatter plot, and try to show that whether the variability is constant or it is increasing or decreasing over the range. So figure and axis object, again initialization, you know that axis dot scatter. So predicted value in the x-axis and residuals in the y-axis. Okay, and if you add the and I also adding the excess label and then removing the splines. If I plot that, it will show that no, it is actually heteroskedastic. Actually, it is not homoskedastic. So it is a heteroskedasticity problem, and to rectify, you have to go for other methodology where you have to correct the errors. That is called, I guess. There is methodologies there. I can't remember right now, but you can also correct this by using the standardized error, I guess. So you can see that the predicted values 1, 2, 3, 4, 5, 6. So it is the tip values. At the lower range value, it is very near the predictions residuals. The actual value and the predicted value difference is very less. Just hold. Okay. So for the lower range values, for 1, 2, 3, it is very nearly scattered, and it is the residual. Residual means what is the actual value of the tip data set and what is the predicted one. Okay, so it is very small, near the zero. But as trying to predict the larger tip value, the error is more. That means for larger tip value, it's not able to predict it correctly. Okay, so that is one problem. That is a violation of one of the assumptions of the linear regression. Second is the assumption is that the residual should be normally distributed. Okay, so you can also plot. We have the residuals, and if I plot that residuals, it will look like almost normal, but it is either it is normal or not. We can also go for a QQ plot. So again, the scipy.stats we are using. So let me correct stats as SS. So ss dot as a probability plot we can use, and if I plot that, it will give me that yes, it is almost normally distributed because it is fitting over the line. So these are the two most important assumptions that you need to be verify while fitting a linear regression model. In this segment, I haven't shown that how to divide the data into train and test, build the model over train, and then test over the test data set and see the different metrics like whether the RMSE, MSE. I'm not showing this. You can also do that. It is also available with scikit-learn. But due to time constraints, it is right now around 6. So that part, up to that part, we are able to conclude here. But if you, this is for just regression part. If you would like to learn as a classification part, I have almost all type of blogs. You can go that. I'm not promoting, but just to compensate the time, you can go for this. Okay, so I have written for R also, it is there, and for Python also there for classification problem. I'll so just go through the things. Okay, so here we would like to predict the a classification. We'll solve classification problem where there is a two-case binary case that whether a person has diabetes or not based on some medical test statistics. Like here I will show the data that the independent variables are like the whether the it is for female only. Okay, the data set is for female, the sex column is not there. So whether the person is pregnant, number of times pregnant, what is the plasma glucose level, then whether diastolic blood pressure, independent variable 4 is tricep skin fold thickness, 2 hour serum insulin, different measurement has been taken for each person, body mass index, then pedigree, diabetes pedigree function, and age. And we are like to predict whether the person is diabetic or not. Okay, so we would like to create a model. I want to save, and we want to use that for further to diagnose any other person. So again, we are using this Pandas, PLT, and Seaborn. We read the data set. Then this is the data set, and we check the info. And we can directly see that the diabetes is a binary case, so we can't fit a linear regression. So in logistic case, it will add because it is like 1 and 0 over the pedigree range, and you have to fit a S curve or S function, S type of function that will give us the probability. So above 0.5, you can imagine if any data falls above 0.5, it is a threshold, then it is classified as diabetic. If it is below 0.5, that would be non-diabetic. This threshold you have to also identify. That is one of the issue that you have to resolve using trial and error. Then data preparation part, that I have mapped the data to negative to 0 and positive to 1 because the diabetes was given in 0 and 1. Actually, the data set was in 0 and 1. Our outcome or target column that we would like to predict. So I have converted it to a numeric one. We're using the map function. And next, the info, majority of the cases it is integer, 2 cases mass and pedigree are float. So you can also try the correlation. I haven't tried here, shown the correlation, how to remove the variables. I have direct approach the describe function. Then model fitting. Model fitting is like, in this case, I use the scikit-learn model.selection, imported the train split. It will split the data into train and test. So this train test model, you have to give that whole data set. In test size, you have to give the 20%. So the test size, I will keep 20% and 80% for train. A random state is given 42 so that I can reproduce. Else what will happen if every time you will run this code, it will generate different samples for train and test. So I've saved this in trains data and test data. Okay. The next thing is a little bit, I can zoom it. Okay. From statsmodels.api sm. Again, I'm using the statsmodel.formula.api import as a logit. And inside, I have a formula that diabetes is predicted by pregnant, glucose, same, all this continuous data. That's why I'm not using this C version, C in bracket, because that was for categorical data. If you want to include a categorical variable, that could be applicable there. And you can also change the reference level. So here, all the continuous data. So pregnant, glucose, pressure, tricep, insulin, mass, pedigree, age. And then I'm giving the formula in the logit and data equal to train data and fit. Here I'm using the train data because I'm keeping the test data aside. In machine learning, when you will learn, there is a terminology called normalization. Data normalization is very much required, but I haven't done it. Just it is to show for that it is for research. in research cases, we usually not normalize, but in machine learning cases for CS department, they usually normalize the data when for image classification. It is very much required because it increases the training process, make it faster to optimize, actually make the optimization faster. So again, the fit, now it will give us the result. Here is the result. Pseudo R square is there. It will report the McFadden and pseudo R square, and there are other R square, but it is not similar to the linear regression R square. It is just likelihood ratio based R square. Okay. So also it is given the likelihood ratio, it is significant. That means at least one variable able to predict our diabetes. Then here the coefficient in linear regression case, if you know that we have directly interpreted it, like 1 unit increase in the X, what would be the Y, holding all other variables constant. But here we can't do that because this terminology is in log odd terms, because it is a not linear regression, it is a classification, binary logistic regression. If you go through the algorithm, then you will realize that the coefficient that returns, it returns as a log odds. Okay. And here the p values, g values, same coefficients plot, all the variables are same, just the coefficient interpretation will be a little bit different. So for classification case, if you exponentiate these values, it will give you odd ratio. Sometimes in bio it called risk ratio. In like survival analysis case also it's called risk ratio, or some ratio is there, but normally it is called the odds ratio. So what would be the odds? 1 unit change will increase our probability by what much? Probability of diabetes by what much? Okay. So next thing is odd ratio. Odd ratio is event occurring but event not occurring. So probability upon 1 minus is the probability. So odd ratio is equal to odds of one thing but over odds of another thing. So odds not equal to probability, first of all. And then we will exponentiate all the variables. So it can be interpreted like 1 unit as a group. If I go for this pedigree variable, so 1 unit change in the pedigree will increase the diabetes probability, having diabetes 3.4 times. That shows actually like this. You can also go for marginal effects, like linear regression, how we have interpreted the 1 unit change will increase in the X, how it will increase in the Y value. So in as it is a log odd terms, so we can also estimate the marginal effects that also available. You can read over like marginal effects overall, mean, at median, at zero, at all. So I'm estimating here over the average marginal effects. So average marginal effects, now it would be like this. If you give from model get marginal effects at overall, method is dy dx, and it gives us the summary. And this summary now could be interpreted that 1 unit increase in say pedigree will increase the probability of having diabetes by 16.77%. Okay, so it could be expressed as now percent. So 1 unit increase in pedigree increases the probability of diabetes by 16.77%. That could be the interpretation. Okay. So percentage interpretation, like here I've shown that interpretation of the AME is similar to linear model. For example, the AME value of pedigree is 0.1677, which can be interpreted as the unit increase in pedigree value increase the probability of having diabetes by 16.77%. So model evolution part, that would be a little bit complex. I will not cover everything because model evolution is a huge task. Just I will show the confusion matrix, and then I will skip to the accuracy, and then I will end this session here. So confusion matrix is nothing but we have the original column of diabetes, which has some of them of 0 and some of them on 1. Now our model will, when we give the model our test data set here from cycle and dot matrix, I have imported the classification report and accuracy score. Okay, so the model, it has our model object we have saved in model. So dot predict. Now we are giving the test data and asking it to predict the classes like 0 or 1, whether the particular row corresponding will be a 0, that is non-diabetic, or diabetic. And this prediction and the cutoff value, I have already showed that S curve, that 50% above it will be diabetic, below that it will be non-diabetic. So I have given the cutoff value. So np dot where prediction value, it will give us the probabilities. So where the probability is greater than the cutoff value, make it 1, else 0. So if it is greater than a cutoff value, our 0.5, then make it as a diabetic, else not diabetic. So we have saved this in Y prediction. And our actual also data that contains 0 and 1, the test data set has a column that has the diabetes column, the actual diabetes one. This one the prediction, and this one is our actual data set we are saving in the Y actual. So if I make a confusion matrix that how many zeros in our actual data set are predicted actual zeros by our model, and how many actual ones are predicted are actual ones, and how many it has ignored or not able to predict. So using the cross tab, I have created this confusion matrix. So the predicted column, predicted is the columns and actuals are the rows. So how many actual was 0 and how many able to our model predicted? 44. And how many was actually 1 and our model has predicted it's 24. And how many ignored? It is 1 but predicted 0 is 11. It is 0 but predicted 1 is 8. So this is the total margins of the total column sum or row sum. And if you also calculate the accuracy, it will give you accuracy of 75.9%. There are other metrics, but I will not go for that. You can directly also use the accuracy score where you give the y actual and y predicted. It will give the accuracy. And there is a classification report, but I will not go for this, like what is a the precision recall. This is another topic and it's a big topic to understand. So it also gives this kind of precision recall F1 score that where you can compare. The dataset and code is also there. Okay, I will just post this if you would like to go. You can go for this blog. Okay. So the code and data is also available in my GitHub repository. Here you have to look for that linear regression or logistic regression, how to create diabetes prediction model, experiment diabetes prediction classification pie-caret, modeling logistic regression using R, modeling is using Python. Here is the code. Directly you can go get the IPython notebook and CSV file. IPython notebook, you can also copy the whole code will be there. Okay. I hope this is a brief introduction because it is a very vast topic we can't cover in 1 hour. At least we tried our best to give you an overview what is machine learning, what is deep learning, how to what is a regression, what is a classification problem, and how to solve what is the should be the approach. Okay, and how you should learn, and that this also I will share if you would like to go for that, the different books, and that would be a guide if you would like to learn it in more detail. And beginning of machine learning, that was here. I can go for the original article because I have taken a subscription of this Medium blog. So this Medium blog is very good where you can
this one and this one.
Okay, I'm sharing them. So these are the machine learning concepts. And this one, the Medium blog. So you can take subscription. This is very good here. Many people post about machine learning, algorithms, anything. If you would like, you can read it there. It is a very good blogging platform. You can write your own blog. So I write mine. And this is my publication also. If you would like to read, I will share the link. If you would like to read, you can also read from here. And that is sometimes that is also free. You can also now IIT Guwahati also given me access. Earlier it was blocked somehow. I don't know. It is my own personal blogging site. You can also visit. It is free. So now we will try to wrap up because it is 6:10. I hope if you have any doubt, you can post. You can post in the group of this WhatsApp group. We will try to resolve. And share. We will also share you the feedback link today and the assignments in 2 days. We need some time to create that also. So okay. So I hope you have learned so much things that we have learned over the years, and it is not you will not learn everything, but you should try to approach whatever you want to pursue, whether you want to be a developer, you want to be a data scientist, you want to be a scientist, you want to be a professor. Just learn the Python is an amazing language, and it is not the only tool. You can learn other things too parallelly. Okay, so that to remember, whatever thing can be solved with a particular tool, learn that. There is no requirement that you have to stick with Python only, but it is a wonderful language, and it is now the ready to go language for data science and analytics. So I hope you have learned something. If you have to write, you can write in the comment box. And now we will close the session, and that would be today's last session. And Best of luck to all. Anything you can write in the chat. Otherwise, in 6:15 we will close. I will close the recording. Durga sir, you want to add something? Because it is the end of the session. If you want to say something, you can say.
Thank you for all your patience and being in the session for so long. So we'll this is not end of the of the support from our side. We will continue our support for any query. So the best ways to explore is to you have already learned the basic. Explore the area that is usable to you in your day-to-day life, and then you will be more motivated to learn the concepts of the Python. And yeah, yeah. Thanks to you too. And so find the area where you can apply the Python concept, the machine learning concept, data science concept, like the on daily basis, and use that area to learn the concepts of the Python and the machine learning and data science. So in that way, you will be more motivated and you will learn slowly. The journey of learning the Python or data science is not you will learn everything and then you will start implementing. It is the other way around. You find the area where you want to implement, and in that process you learn. Thank you everyone. Bye.
Okay, I'm closing the session right now. If you have anything, you can write in the chat or in the WhatsApp group. And SAB member can close the recording. Okay, I'm closing the session. Recording will be stopped by our SAB members. And thank you.